a successful design of column, you should be accurate while deciding if your column is axially loaded, or if it is subjected to a uniaxial moment, or if it is subjected to a biaxial moment. The common word among these three classes is axial. Axial is derived from axis, and a column can only support a beam or a slab in just two axes, which is the x and the y axis. What is axial, uniaxial, and biaxial column? If a column is only loaded vertically without receiving any moment from the surrounding beams it is supporting at both x and y axes, we say the column is an axial column. If a column is loaded vertically and also receiving moment at one axis due to the surrounding beams it is supporting, it is termed a uniaxial column. It is a uniaxial column because it is receiving moment at just one axis. That is why it is called uniaxial. Remember, uni means one, axial means axis. So uniaxial means one axis. When a column is receiving moment from one axis, it is a uniaxial column. If a column is loaded vertically and also receiving moments at both axes due to the surrounding elements it is supporting, we refer to it as a biaxial column. You understand? It is biaxial because it is receiving moment at the two axes. Bi-axis. Bi means two. Now, how do you identify an axial, uniaxial, and biaxial column? Just by looking at the general arrangement plan. There are 5 ways in doing that. 1. If a column is situated exactly at the center of both x and y axis of the element it is supporting, the column is an axial column. So look at this column. It is supporting 4 elements, 2 at the x-axis and 2 at the y-axis. The elements in the x-axis, they both have equal length. I mean, the one at the right has the same length with the one at the left. Also, the element at the top of the y-axis has the same length with the element at the bottom of the y-axis. So it is situated exactly at the center of the x-axis, also exactly at the center of the y-axis. Thereby, it is an axial column. Number 2, if a column is situated at the center of only one axis, it is a uniaxial column. So looking at this column also supporting 4 elements, the element at the right has equal length with the element at the left in the x-axis. But what about the y-axis? The element at the top has a greater length than this one at the bottom. Thereby, this is a uniaxial column. The difference in the length will determine the moment. You understand? Because moment is the multiple of load and distance. The assumption is that the load is equal, only the length differs. So for the x-axis, we have equal length. It means the moment at the left will be equal to the moment at the right. Therefore, the two moments will cancel out and there will be no resultant moment generated in the x-axis. But what about the y-axis? There is a difference in the length of both elements in the y-axis. Thereby, there will be a resultant moment in this only one axis, and that is uniaxial. Number 3, if a column is situated at neither the center of both axes, it is a biaxial column. So looking at this column, at the x-axis, the elements do not have equal length. The same thing at the y-axis, they do not have equal length. So this is a biaxial moment. It will be receiving moment in the x-axis, also receiving moment in the y-axis. That is 2 moments, meaning bi-moment, biaxial. Number 4, if there is only one element in a particular axis, the column is uniaxial in that axis. Looking at this column, it is different from the other columns you've been seeing so far because it is supporting 3 elements, 2 in the y-axis and 1 in the x-axis. There is no element at the left of the x-axis that will also produce a moment which will counteract this one at the right. Therefore, there will be a resultant moment in the x-axis. So you can say it is uniaxial in the x-axis. So this column is a uniaxial column. Number 5, if a column is situated at the corner of the panel, it is a biaxial column. So whenever you have a column at the corner of a panel, it is a biaxial column. The rule that guides number 4 is the same rule that guides number 5. Because if you look at this column as well, it is only having one element in the x-axis, meaning it is uniaxial in the x-axis. The same thing goes for the y-axis. It is uniaxial in the y-axis because you only have one element in the y-axis. So uniaxial in the x-axis, uniaxial in the y-axis will make the column to be biaxial. Now let's take an exercise with this general arrangement with the 5 points that we've learned. The total columns here is 18 and labeled from C1 till C18. The dimensions are given in millimeters. Now let's begin. C1, C4, C5, C9, C10, C14, C15 and C18 are biaxial column because they are corner column. They are situated at the corner of the panel. C2 is a biaxial column because it is not at the center of the x-axis nor the y-axis. If you look at the x-axis, the total length is 7,000, 3,000 to the left, 4,000 to the right. So the center should be 3,500, but it is 3,000 from the left. So it is uniaxial in the x direction. What about the y direction? There's only one beam, and as we've known from point 4, that means it is uniaxial in the y-axis as well. So uniaxial in the x, uniaxial in the y, that makes C2 to be a biaxial column. C3 is a uniaxial column. It is located at the center of the x-axis. 4,000 to the left, 4,000 to the right. But what about the y-axis? There is only one beam in this direction, thereby it is uniaxial in this direction. Therefore, C3 is a uniaxial column. C6 is a uniaxial column because of the x-axis. To the left, we have 2,800. To the right, we have 3,000 mm. It is not at the center. What about the y-axis? We have 3,200 here, 3,200 here. So it is only uniaxial in the x-axis. So we can say C6 is a uniaxial column. C7 is a uniaxial column because the beams at the x-axis do not have equal length. C8 is an axial column because the beams in the x-axis have equal length. The beams at the y-axis also have equal length. C11 is a biaxial column because it falls at neither the center of both x and y axis. C12 is also a biaxial column for that same reason. C13 is a uniaxial column because of its y-axis. C16 is biaxial and C17 is uniaxial.